Good morning, students. Today we are going to learn about flip-flops. Flip-flop is a digital circuit or sequential circuit used to store a single bit. It can be either 0 or 1. Flip-flop can be constructed by using NAND gates or NOR gates. Okay. Flip-flop can be activated by the clock pulse. Okay. Flip-flop has two output states, Q and Q bar. To activate the flip-flop, you have to apply clock pulse. Okay. So now I am going to explain about RS flip-flop. Okay, there are four types of flip-flops: RS flip-flop, JK flip-flop, D or delay flip-flop, and T or toggle flip-flop. Okay, RS flip-flop, JK flip-flop, D or delay flip-flop, and T or toggle flip-flop. Okay. Before that, I want to say about what is triggering. Okay. This is the clock pulse. Okay. This 0 to 1 transition is called positive edge. This 1 to 0 transition is called negative edge. This is the high level, this is the low level. Okay. What is trigger? To activate the flip-flop, we apply the momentary input at the input side. This momentary change in the input is called trigger. The process of giving trigger is called triggering. Okay. Triggering can be classified into two types: edge triggering and level triggering. Okay. Edge triggering again can be classified into two types: positive edge triggering and negative edge triggering. Similarly, you can classify the level triggering into two. One is high level triggering, next one is low level triggering. Okay. When we apply the clock pulse, during the transition of 0 to 1 in the clock pulse, the output of flip-flop will be changing, means then it is called positive edge trigger. Okay. When we apply the clock pulse during the transition of 1 to 0, the output will be changing, then it is called negative edge triggering. Okay. Similarly, when we apply the clock pulse during the high level, the output will be changing, then it is called high level triggering. When you apply the clock pulse during the low level in the clock pulse, the output of the flip-flop will be changing, then it is called low level triggering. Okay. Okay. This is the circuit for RS flip-flop. This is the symbol for RS flip-flop. Okay. RS flip-flop consists of two inputs and two outputs. To activate flip-flop, we have to apply clock. Okay. So there are two inputs, set and reset. Okay. S denotes set, R denotes reset. Okay. Q bar always complement of Q. Okay. Q is the output state of flip-flop. Okay. Set and reset are the inputs of RS flip-flop. Q and Q bar are the outputs of RS flip-flop. Q is the output state of flip-flop. Q bar is the complement of the output Q. Okay. So S can be either 0 or 1, or can be either 0 or 1. we have two inputs. So there are four possible combinations. Okay, 0 0, 0 1, 1 0 and 1 1. First I am applying S is equal to 0 and R is equal to 0. Okay. Okay. So S is equal to 0, R is equal to 0. Now I am applying clock pulse. Okay. All of you remember that in NAND gate, if any one of the input is 0, then the output will be 1. Okay. All the inputs, that means if both the inputs are 1, then the output will be 0. Okay. If any one of the input is 0, the output will be 1. Both the inputs are 1. If both the inputs are 1, then the output will be 0. Okay. So now S is equal to 0. So if any one of the input is 0, the output will be 1. So the output of this NAND gate will be 1. Similarly, here R is equal to 0. So if any one of the input is 0, then the output of the NAND gate will be 1. So the output of this NAND gate will be 1. Okay. Now we have 1 at the first input. In this we have 1 at the second input. Okay. But we don't know the second input of this NAND gate. Similarly, we don't know the input of first input of this NAND gate. Okay. So now I am assuming that Q is equal to 0. In the first case, I am taking Q is equal to 0. Now this Q is applied to this NAND gate. So here we have 0. So if any one of the input is 0, then the output will be 1. Okay. So now Q bar is equal to 1. This 1 is applied to this NAND gate. Now both inputs are 1. So you will get the 0 output. Okay. 0 output. So now we are getting the output Q is equal to 0. In previous case also Q is equal to 0. So when you apply S is equal to 0, R is equal to 0, then no change in the output. Okay. If you take Q is equal to 1, after applying clock pulse, you will get the same 1. So when S is equal to 0, R is equal to 0, there is no change. Okay. Next I am applying S is equal to 0, R is equal to 1. Okay. S is equal to 0, R is equal to 1. Now I am applying clock pulse. Okay. If any one of the input is 0, then the output will be 1. of this NAND gate will be 1. Okay. Here both are 1. Now I am applying clock. Okay. So here also we have 1. So both inputs are 1. So the output of this NAND gate will be 0. Now if any one of the input is 0, then the output will be 1. So Q bar is equal to 1. Okay. If any one of the input is 0, then the output will be 1. This 1 is given to the second input of this NAND gate. Okay. So now we have 1. Here also 1. In the second input also we have 1. So both inputs are 1. So we will get Q is equal to 0. 0. Okay. So if S is equal to 0, R is equal to 1, then the output will be 0. Okay. Now the output of the flip-flop is cleared. Okay. To clear the flip-flop, you have to apply reset is equal to 1. Okay. When you apply reset is equal to 1, the output becomes 0. That means the flip-flop will be cleared. Okay. So to clear the flip-flop, you have to apply reset is equal to 1. Okay. Next I am applying S is equal to 1, R is equal to 0. Okay. S is equal to R is equal to 0. Okay. Now I am applying clock pulse. Okay. If any one of the input is 0, then the output will be 1. So here of this NAND gate is 1. Okay. Here both inputs are 1. So the output of this NAND gate will be 0. Okay. Now here we have 0. So if any one of the input is 0, then the output will be 1. So Q is equal to this one is applied to this NAND gate, lower NAND gate. So both inputs are 1 now. So if both inputs are 1, then the output will be 0. Q bar is equal to 0. Okay. So please note it here. If S is equal to 1, R is equal to 0, then you will get Q is equal to 1. Okay. To set the 1 at the output of the flip-flop, you have to apply set input is equal to 1. Okay. To clear the flip-flop, you have to apply reset is equal to 1. To set the value 1 at the output, you have to apply set input S is equal to 1. Okay. Next. next I am applying S is equal to 1 and R is now I am applying clock pulse. Now we have 1 at the input of first input of NAND gate. In the second input also we have 1. Okay. So if both inputs are 1, then the output will be 0. 0. Here also both are 1. So the output of this NAND gate is also 0. Okay. If any one of the input is 0, then the output will be 1. So now Q is equal to 1. To 1. Here also we have 0. So if any one of the input is 0, then the output will be 1. So Q bar is equal to 1. Okay. Now all of you listen here. Here Q is equal to 1. Q bar is also 1. Okay. Q bar should be complement of Q. Okay. If Q is equal to 1, then Q bar should be 0. If Q is equal to 0, then Q bar should be 1. Okay. If Q is 1, then Q bar is equal to 0. If Q is equal to 0, then Q bar will be 1. Here both are same. Okay. So this is undefined state. Okay. So if S is equal to 1, R is equal to 1, we will get Q is equal to 1, Q bar is equal to 1. So this is indefinite. Okay. So this is the working of RS flip-flop. Okay. When you apply S is equal to R is equal to 0, then no change in the output. If you apply S is equal to 1, R is equal to 1, you will get Q is equal to 1, Q bar is also 1. Q bar, actually Q bar should be complement of Q, but in this case both are same. So this is the undefined state. Okay. To clear the flip-flop, you have to set the reset is equal to 1. To set the flip-flop 1 at the output, you have to apply the set input S is equal to 1. Okay. This is the working of RS flip-flop.